Hi there, welcome back to Weather Analysis. And we're going to be looking at an introduction to numerical weather prediction. So first of all, what is numerical weather prediction? This is the model data that we are the most familiar with on a day-to-day basis. Um, the important thing is to make sure that you know how the model is doing in the current hour. If the model is not doing well with the conditions that we have now, we shouldn't expect it to be doing well for the future. So there are three processes that we're going to talk about right here. Um, Assimilation, analysis, and initialization. Assimilation is the process of blending observations with a short-range numerical weather model. So it's the process of blending observations. Analysis is the product of comparing the previous model run to a new observational data, um, which is our forecast hour zero. Initialization is where the updated model is started. What does NWP use? Well, the first thing that it does is it uses parameterization. And what this means is we are limiting the model to some parameters, since including all the data would require too much computing power that we don't have, time and power that we don't have. So it just limits the data to certain parameters that it finds, and partially how this is done is through equations and methods from Newton's laws, conservation of momentum, conservation of mass, conservation of energy, and ideal gas law. Then there's post-processing, which we have model output data that's converted from model coordinates to display coordinates. We make sure that the biases and deficiencies are filtered out, and we interpolate vertically and horizontally. Now, with this, you might expect that there could be some inaccuracy, and that is true. We know that there is inaccuracy in our forecasts, but this is the best thing that we can do at this time. In 50 years, this video probably doesn't even matter anymore, but that's the thing, you know. Okay, so three types of models. So we have grid point models. This is the simplest type of model. Data is converted to an array of grid points. Model equations are applied to grid points to produce a forecast map. So this is just using the grid 3D of the Earth. Then we have the spectral model. Data is mapped on mathematical waves, which are later converted into geographic coordinate system to provide forecast map. Dynamic models try to simulate the atmosphere physically and try to model changes in flow, heat, and humidity. Then we have two types of domain. Global domain, which takes into account weather across the entire Earth. Um, there are no boundary errors, and what we mean by boundary error is in the case of limited domain, it's just a specific region of the Earth. So there's a boundary. So on that boundary, we have more inaccuracy um, than we do in the central part of that region. But but that's why there's no boundary errors with global domain, because we're using the entire Earth. So obviously, using the global domain requires more computing power, but in the end is more accurate, but does not have as high resolution. We have higher resolution with the limited domain, but more errors. So there's give or take for both. Um, Forecasts beyond 48 hours become increasingly challenging for limited domain and somewhat inaccurate. That's going to be it for this video. Thanks for watching.